Hi, this is K. Krishna, rule number 20951A2130, branch aeronautical engineering. So today my topic is ground-based new radar system enables UAVs to avoid collisions. Ground-based systems helps UAVs to avoid collisions. Thus, a new radar system enables unmanned aircraft to see and avoid other aircraft. The Federal Aviation Administration (FAA) is averaging more than the 100 reports a month of interaction between unmanned aircraft systems and commercial or private planes. This statistic gives cause to ask, how can unmanned aircraft avoid in air collisions? For an unmanned aircraft systems UAS to fly in civil airspace, it must be able to see, avoid, and remain well clear of other aircraft, with no pilot on board to spot approaching aircraft. Another sense and avoid SAA technique is required. To address this need, Lincoln Laboratory developed the ground-based sense and avoid GBSAA system, which enables a UAS to detect and steer clear of other aircraft. The US Army has been funding research at Lincoln Laboratory to develop this system with the help of SRC Inc. and DOT technologies. Rather than using onboard sensors, which are still in the development phase, to provide the location of neighboring aircraft, the GBSAA system uses existing radars to locate nearby aircraft, including those not tracked by FAA systems. Data gained from the radars are processed by unique algorithms so that the system can locate and prioritize the risk from all aircraft, and then the issue alerts to the pilots of the UAS at risk and compute the optimal avoidance maneuver. This arrangement allows This arrangement allows the GBSAA system to provide sense and avoid services to any size UAS flying within radar coverage without requiring the UAS to carry an additional equipment. We developed a much more sophisticated conflict detection and avoidance logic than that used by the aviation industry in the past. Lincoln Laboratories developments in system architecture, threat detection, manual algorithms, and analysis in this program combined to offer an important advancement in the UAV industry. The risk of unmanned aircraft hitting other aircraft is a huge regulatory concern, said Ronald Cole, assistant leader of Lincoln Laboratories Surveillance Systems Group. GBSAA technology greatly reduces that concern. The GBSAA is the first system that provides both situational awareness and maneuver guidance, can be used for long duration flights, and meets the stringent FAA requirements for flight safety. The GBSAA is the first system that provides both situational awareness and maneuver guidance, can be used for long duration flights, and meets the stringent FAA requirements for flight safety. The key breakthrough is the use of cutting edge computing science and logic design, Cole said. He said they developed a much more sophisticated conflict detection and avoidance logic that used by the aviation industry in the past. The logic uniquely accesses not only the current location and velocity of each aircraft, but also the uncertainty in these data and potential future threat aircraft maneuvers to determine the threat posed by each nearby aircraft an optimal set of maneuvers for the US to regain a position of well clear, a priority ordered list of which US may violate the requirement to remain well clear. The workload challenges to the UAS pilot if the pilot changes maneuvers. For example, a rapid change between a command to turn right and a command to turn left. This is the display how they can operate. This is the alert display and one is the traffic display. Here we can see the GPSAA operator shown above views data from radars and then communicates with the UAS pilot and the air traffic controller. The best method to maneuver to avert possible collisions. Image courtesy of the research team. The GVSAA ground control station processes data from up to 6 radars and accesses the air surroundings of up to 6 UAS. The GBSAA operator GBO shown above views data from the radars and then communicates with the UAS pilot and the air traffic controller of the best method to maneuver to avoid possible collisions. The GBO has access to two displays, an alert display and a traffic display. An alert display contains all the information needed for each aircraft to maintain a safe separation distance from other aircraft. A traffic display provides a broad area picture of air traffic to allow the GBO to fully understand the local situation and to plan ahead for potential conflicts. The core technology can be readily adapted to support drones engaging in package delivery, hurricane damage assessments, and search and rescue efforts, or applied in emerging technologies like automated air taxi services. Today, unmanned aircraft face a wide range of restrictions because of the concerns about unmanned aircraft hitting other aircraft. The ability to detect and mitigate this risk will facilitate huge growth in the UAS industry. Thank you.